Solve the given linear system graphically. Question 7. Y equals to 3x minus 4 and y equals to minus 1 over 3x plus 1. Both the equations given to us are in slope-intercept form, so we can sketch a graph with both these equations. The point where they meet is actually the solution for our linear system. As you know, linear system is a system where we are dealing with more than one line, and here we have two lines, and therefore it is a linear system. And solve means wherever they intersect, that's the solution of two linear systems. Okay, now y equals to 3x minus 4 has got a y-intercept at minus 4. If you put x as 0, you get y equals to minus 4. That is what it means when we say y-intercept of minus 4. So minus 4 is our first point. Second point we have to take with the help of slope. Slope is 3. That means rise of 3 and run of 1. So let's move. Rise 3. 1, 2, 3. And run of 1. Right? So simple to get the next point. And then we get a point. And let me mark this point. Correct? Then again we can go rise of 3. 1, 2, 3. And run of 1. Which is here. And that gives us another point. Correct? Now with these points joined together, we should be in a position to draw our line. So our line is going through these points, a straight line going through these points, correct? So there we are, and I think they're aligned. Once aligned, just sketch the line. Okay, and draw some arrows here and here, correct? So that's the first line, which is y equals to 3x minus 4. And now let's try to sketch the next line. So what is the y-intercept of the second line? The y-intercept of the second line is 1 plus 1. So let's mark this plus 1 here, correct? And now let's again see rise over run. Now slope is minus 1 over 3, correct? Let me write down the slope separately. Here, slope m is minus 1 over 3. So rise of minus 1 and run of 3, that is one option. So let's do that. And that is minus 1 means one step down, correct? And 3 to the right. And let's do 3 to the right, which is 1, 2, and 3. And we reach this place. And let's mark this point as the second point of our line, right? And now, since we are running out on this side, we can try one on the other side. The other side means instead of taking numerator as negative, we could take denominator as negative. So we can write this as 1 over minus 3. That is same thing, minus 1 over 3. So in that case, we'll go up by 1 and left by 3. So let's go up by 1, correct? And left by 3. So which is 1, 2, and 3. And we land up into another point. So we have 3 points here. Good 3 points to join and get us the equation. Rather, sketch of the line. Now this is the line joining these 3 points. Okay, there we go. So as you can see, the line meets somewhere in the middle. Now in such equations, to write down precise answer is so difficult. That's the point where our line meet. Now it's so difficult to figure out what is the real solution. So we need some approximation and a good judgment. Now from here it seems as if it is right in the center of my square. At least x value is, I know, half of 1.5, correct? So let me put x as 1.5, correct? And well, so we have to make a judgment here and say, well, the point of intersection is here, and that's our solution. To write it in the coordinate system, we'll say, well, p is 1.5 and x value is 0.5, correct? So that is our solution from the graph. So that's the best we could give from the graph, correct? Well, sometimes what you can do is, if you got the x value 1.5, you can plug in x value here and get the y from the equation. And let's try that also. Okay, so y equals to, we are assuming this point to be half, right? So 3 times 1.5 minus 4. So 3 times 1.5 is 3 times 5 is 15, 3 times 1 is 3, and 1 4, right? So we get minus 4, and we do get 0.5. That seems to be quite okay. So for the time being, we'll assume and take that as our solution, right? But at times it is tricky. So there are some approximations when we are trying to find a solution graphically, and that is acceptable. Okay, thank you.